So friends, in today's video we shall be looking at the correction of the Cameroon Ordinary Level Physics 2024. We shall look at the section A part of this question, which there were 6 questions guys, and you answer all the 6 questions guys for a maximum of an hour. So friends, we shall look at this section today friends, and if there's something you don't understand, please feel free to leave your worry in the comment section down below guys, so I can get back to you to make you understand as soon as possible. So guys, if you're new to this channel and you've not subscribed guys, make sure you subscribe to this channel, because that is the only way you join the academy, where we help students to pass their exams with very good grades. And we can only do so guys once you have subscribed to this channel. Friends, please give this video a like and share the video out with others. Friends, you watching this video now makes you so special, but you owe your friends the opportunity of sharing this video out to them. So please do so. Share the video out with them. If Homework Academy has helped you to have access to this video, you should also help your friends to have this video as well. Just click on the share button beneath this video. You're going to share it out with your friends. Okay, now guys, and again, we have a WhatsApp group where we help students. I will leave a link to those WhatsApp groups for those who are taking the advanced and ordinary level in the description of this video for your convenience. If you don't know how to navigate through the description guys, if you're watching this video online, just click on the title of this video. It will take you to the description of this video. Okay guys, let's get started. The first question is saying that we should define pressure and state its unit of measurement. Then the next part says I should explain why a sharpened edge knife cuts meat easier when a constant force is applied. And the B part is saying that we should explain that we should calculate the pressure exerts at a depth of a 6 meter in a pond, given that the density of water is 1000 kilograms per cubic meters. Okay, so guys, let's start. So friends, to define pressure, we know that pressure is simply defined as the force acting per unit area. Great. So guys, whatever force you have that acts at a particular area, that force can be termed as the pressure exerted at that particular point. So guys, this is very easy. You define it as a force acting per unit surface area or per unit area. Great. You can look at some textbooks that will tell you that pressure is defined as a force acting perpendicularly or normally per unit area. That is still correct. Okay, that is still good. But at the ordinary levels, if you tell them that pressure is defined as a force acting per unit area, you are perfect. That's good. Okay, the next part wants us to explain why a sharpened edged knife. Oh my god guys, the SI unit of measurement guys is the Pascal. Okay, is the Pascal. And note guys, note, if you're my student that I'm teaching you physics, make sure that, in fact, all those taking physics at the O level, please, even at the advanced level, don't make the mistake of writing the Pascal with capital P, because the Pascal being written with capital P is the name of the person whose name was used as the SI unit. Okay, but if you're writing this as a unit, you need to start with small p, okay, with lowercase p. But if you're writing out the symbol, you need to start with capital P, small a. Please take note of these conventions. They are so important. Okay, the next part wants us to explain why a sharpened edge knife cuts meat easier when a constant force is applied. Okay guys, let's know that a sharp edge knife obviously friends has a very small surface area of contact. So now if we look at the equation from P equal to F over A, where P is the pressure, F is the constant force being applied, and A is what the cross-sectional area, right? It therefore means that our pressure in this case guys is inversely proportional to the area. And friends, this is true whenever we have the force, as the equation has said, to be a constant, right? That's a constant force. So friends, to explain this concept, you need to use the formula to get the pressure, because when the force is constant, the pressure is inversely proportional to the area, which this simply means that friends, if you increase the area, the pressure obviously reduces, and the knife will not be able to cut meat easily. But friends, if you decrease the area, right, if the area gets reduced or the area gets very small, you notice that the pressure becomes what? Very high, and it is going to be very easy to cut your meat. Great. So guys, that's it. Okay, now, so friends, here's the explanation. everything has been explained, right? You can also be asked to explain why a knife that has a very large surface area does not cut meat easily. The same explanation goes, okay? The same thing. You simply have to reverse all what I said. Okay. Now, the next part wants us to calculate the pressure water exerts at a depth of 6 meters. That okay. So for instance, now to get a pressure, we should know that the pressure in liquid, guys, is simply given as raw GH, where this is the pressure of the liquid, raw is the density of the liquid, G is the gravitational friction or the acceleration due to gravity, and H in this case is the depth. So in this case, guys, we notice that the density of water, guys, has been given to 1000 kilograms per cubic meters. Our G, guys, from the back of the paper, they will tell you that it is 10 meters per second squared at the O levels. Then, friends, the height has been given as what? As 6 meters. So if you punch this on a calculator, we have an answer of 6 times 10 raised to the power 4 Pascal. Now, guys, important notes. If you write 60,000 Pascal, you are correct, okay? If I'm marking your paper, I'm going to mark it correctly. But I'll appreciate someone that writes it like this in standard form, okay? Yes, I'll appreciate someone that does this. But if you write 60,000 Pascal, you're still good, okay? So guys, that's it for the question 1. Let's look at question 2. The question 2, guys, as you can see, it's saying that we should distinguish between a contact and non-contact, between contact and non-contact forces. Then the people wants us to explain why an object weighs more when taken from the equator of the earth to the pole. Okay. So guys, contact forces, as the name suggests, guys, a contact force, they are simply forces that act between objects when they are touching each other, or objects in contact, okay? Objects that are close in contact. Great. So that's it. So for instance, the equation might ask you to give examples of contact forces. You can give the friction force, okay? You can give the normal reaction force, okay? These are contact forces and so on, guys. There are so many of these are contact forces. Great. There are so many of them. Then, for instance, while non-contact forces are forces that act between objects which are not necessarily touching each other. Great. So, for instance, the word not necessarily, friends, it's very, very important, okay? If this phrase in red is, if this word in red is missing, guys, I might not give you your marks. Yeah. Okay, that's it. So guys, that's it. An example of this, you can talk about fundamental forces such as you have the electrostatic force, you have the gravitational force, you have the magnetic force, and so on, okay? Those are non-contact forces. Great. Okay. That's it. Okay, the paper also explain why an object weighs more when taken from the equator of the earth to the pole. Okay, guys, let's simply know that the weight of a body depends on two things. One, the mass of that body, and the acceleration due to gravity or the gravitational fusion of the planet, or of the particular point on a planet where that object is found. Okay, so guys, we simply have to notice that at the pole, the value for the acceleration due to gravity, guys, is greater than at the equator of the earth. Okay, at the pole, guys, our G at that point is highly greater than the G at the equator of the earth. So according to our relation, our W, which is the weight, which is equal to mg, where m is the mass of the object, G is the gravitational field strength. It ever means that, guys, if our mass becomes a constant, our W is what? Directly proportional to G. This simply means that, guys, if we increase G, the weight obviously has to increase, and that's exactly what this our statement here says. That at the pole, the value for the acceleration due to gravity is greater. That's why the object weighs more at the pole than at the equator. Great. So guys, that's it. And this happens whenever the mass m is a constant. Okay. The next question, guys, is saying that the table in figure 1 contains part of the electromagnetic spectrum. Okay, guys, this is the table. Okay. Arranged in decreasing order of wavelength. Now, A, identify the radiations X and Y and state how each of them can be detected. The B part gives two differences between electromagnetic wave and sound waves. Differentiate between transverse and longitudinal wave. Okay. So guys, all right, let's get started. So friends, just if you look at the electromagnetic spectrum, guys, the complete spectrum, you will see that I'm trying to match. You see that our X in this case is going to be the ultraviolet radiation, while Y becomes the X rays. Okay, great. So guys, if you look at it so well, if you look at your spectrum so well, guys, be familiar with your spectrum. These are questions that you can just see them and you just give the answers even without thinking. Okay, that's it. So guys, that's, and each of them, guys, can be detected using a photographic film, okay, or you can say a fluorescent screen, any of them, guys, but I prefer you saying a photographic film. Great. So guys, if you don't know what's photographic film, guys, just let me know in the comment section down below, guys, so I can make a video on it as fast as possible to make you understand how the phenomenon, how it is done. Great. So that's it. The next part is now I should give two differences between electromagnetic waves and sound waves. So guys, for the sake of not making the video too lengthy and my space as well, I'll give just one for each. Okay, I'll give just one for each, and you're going to give me the next in the comment section down below. Okay, just give me the one more difference that I won't mention here in the comment section down below. Wait, so I can tell you if it is correct or if it is not correct. So guys, we'll say that electromagnetic waves can pass through a vacuum while sound waves cannot. Keep in mind that electromagnetic waves are simply waves that result from the vibration of fields. The fields in question, friends, are the electric and the magnetic fields, okay? These are waves that can pass through a vacuum. But friends, sound wave on the other hand, friends, is simply a mechanical waves and it cannot pass through a vacuum, okay? That's the best difference you can give. Okay, let's talk about transverse waves. So guys, like I said, we needed to give two differences here, but I've given just one. Okay, I've given just one. So I want you now to give me the next in the comment section down below. If you don't give it, guys, I will not be happy with you. But in fact, anybody that gives a difference, if it's not correct, I'll individually tell the person why it's not correct, and I'm going to explain to that person so well, and I'm going to tell the person the correct answer to put. Okay, transverse wave, guys, let's define transverse waves. Let's define them in terms of how they are propagated, and let's talk about how they vibrate. So for transverse wave, guys, we can see that the particles of the medium, guys, they vibrate parallel to the direction of travel. Wait, the vibrations, guys, are highly parallel to their direction of travel. Where for longitudinal wave, guys, their mode of vibration is perpendicular to the direction of travel. Great. So guys, that's it about longitudinal waves and sound waves. You can also differentiate in terms of examples. An example of a transverse wave, guys, you can say light waves are transverse waves. Longitudinal waves, you can talk about sound waves. They are examples. It's an example as well. Great. So guys, give me more examples about transverse and longitudinal waves in the comment section down below. Okay, guys, that's for question 1, 2, and 3. Let's go to question 4, 5, and 6, guys. Are you ready, friends? Let's go. Okay, guys, here we are. The question 4 reads that figure 2 shows a uniform plank of negligible mass and of length 2 meters on a support E at its midpoint. Two weights of 60 newtons and 80 newtons are attached to it. We should state the two conditions necessary for the system to be in equilibrium. Okay, guys, let's start with the first part. So friends, my students obviously should be able to should be smiling when they see questions like this, right? I've always told them that they should never feel any area as far as I have taught them. Okay, they should not feel any area. That doesn't mean that they should feel the ones I haven't taught them, because I'm going to teach it. But that's not enough reason for you to enter the exam hall and see a question and claim that you cannot answer it. There are enough materials online, guys. You can gain access to those materials and score your grade so well. Okay, so guys, there are two conditions in total. First of all, we can see that the sum of all the forces acting on the system must be equal to 0. So friends, so many students always have some misconceptions about this first one. Okay, in practice, what this first condition is saying is that the sum of the upward forces have to be equal to what the sum of the downward forces, or sum of the forces acting to the left must be equal to those acting to the right. Great. Let's understand. Then friends, the second simply talks about moments, that the sum of clockwise moment about a given point must be equal to what the sum of anti-clockwise moment about that same point. Great. So guys, I'll be saying this one particularly to my students in class. I always tell them that if they just tell me that sum of moment acting on the system have to be equal to sum of clockwise moment acting on the system, I won't smile with them. Okay, I won't be happy, because moment is not being taken on a system, it is being taken at a particular point on a system. Okay, not just on the entire system. It is being taken at a particular point, wherefore when it's taken at that particular point, we assume that all the forces perpendicular to that point are zero. Wait, let's have that in mind, please. Okay guys, these are the 2 points. These are the 2 points you are expected to give. The next part is in that we should calculate the distance x of the 18 Newton object from the support when a system is in equilibrium. Okay, we have to use these our two conditions. So friends, ask yourself, can we use the first condition, which is saying that the sum of forces acting must be equal to zero? No guys, we cannot use it, because we need to get what distance, that is x, right? And these forces are not related with their distances. But we can use the second. Why? Because when it talks about moment, and we know that moment is given as well, guys, the product of force and the perpendicular distance from the pivot. So we can use the second condition. So for instance, now, although this one method was not indicated on the equation, I decided to indicate it so that people should see, because the question is saying that this our plank has a negligible mass, means it has no mass. Okay, or the mass is so small to be taken into consideration. Okay, it's so small. So if it has no mass, obviously it has no weight. Okay, it has no weight. And the question told you that what the plank was suspended at its midpoint. So it therefore means that this point where the plank is suspended, guys, is the center of the plank. Okay, this is the center of the plank. So guys, in this case now, our sum of clockwise moment has to be equal to what, guys? The sum of anti-clockwise moment. Do you see that this 16 Newton force, guys, is capable of causing an anti-clockwise rotation, while the 18 Newton force is capable of causing what, guys? A clockwise rotation. So 16 Newton force, guys, will give us an anti-clockwise moment, wherefore the 18 Newton force, guys, will give us a clockwise moment. So in this case, guys, our clockwise moment has to be equal to a sum of anti-clockwise moment. If we take the moment about the point R, it means that we will neglect the forces acting at the point R. Therefore means R itself has to be 0. So at that point now, guys, our 60 multiplied by 1, which is what the perpendicular distance from the pivot, which is 1 meter, so has to be equal to what, 80 times its own distance from the pivot, which is x. Great. So at this point now, guys, if we divide all through by 80, we have x be equal to 60 over 80. Solving for s, guys, we'll have our x be like 0.75 meters. Great. So guys, this is the answer to our question. Great. So guys, that's it. The next part is now we should get the force R on the plank by the support. So friends, this is when we need to use the first principle I just stated, which simply means that the sum of all the forces acting on the system have to amount to 0. Okay, let's draw a line. Okay guys, let's say that like I was saying, friends, that what this first principle is saying is that the sum of all the forces on the system must be 0, right? It therefore means that in practice, the sum of the upward forces must amount to what, the downward forces, or the left forces have to equal to what, right forces. But we don't have left and right forces here. We only have upward and downward forces. So the upward force is going to be arrow. It has to be equal to what, the sum of these two forces, that is 80 plus 60, which this gives us an answer of 140 newtons. Great. That's it, guys. That's it, guys. Let's look at the next question. The next question, guys, as you can see, friends, it simply reads that we should define interference and name 2 types of interference. All right, so guys, that's what we have. Okay, now let's insert the wave profile that figure 3 talks about. Here is it, guys. Okay, Now, what is interference, guys? So for instance, we can define interference as such. We can define interference as a phenomenon that occurs when two or more waves overlap and combine to form a new wave pattern. Okay, so guys, that's it. Whenever two waves, the waves might either be traveling in the same sense or in opposite senses. They might either have the same amplitude or a different amplitude. Okay, yes, as long as these two waves are capable of overlapping, that therefore means that interference can occur at that point. Great. So guys, we have two kinds of interference. We have constructive interference and destructive interference. Now guys, we are actually the next part. For constructive interference, for instance, their amplitudes are going to what? Add up. Okay, the amplitudes normally add up. The amplitude, guys, are going to add up so well whenever a crest meets a crest or a trough meets a trough. They are going to produce a more big wave whose amplitude is greater than the amplitude of the individual waves. But friends, with destructive interference, you notice that it simply occurs whenever a trough meets a crest or a crest meets a trough. At that point now, friends, the amplitude of the wave has to decrease, or it either remains zero. It either goes to zero. It goes to zero, friends, whenever the two waves have the same but opposite amplitude. Okay, when they have equal but opposite amplitudes, we expect their resultant amplitudes to cancel out. Okay. The next part wants us to calculate the wavelength of the stationary wave. So for instance, note this equation that one student keeps on asking me. So for instance, note that the distance between two successive antinodes, or between two successive nodes, guys, equals what? Half a wavelength. Okay, it's the same as half a wavelength, half of a wavelength. Okay, great, that's it. Great, guys, it is equal to what? Half a wavelength. So in this case, since we have from a to x is what? Half lambda, right? From x to this other point is equal to half lambda. From here is to here is equal to what? Half lambda. So we have what? We have 1/2 lambda plus 1/2 lambda plus 1/2 lambda, which gives us what? 3/2 lambda, right? So it therefore means that the length of this our wave L equals what? 3/2 lambda. In this case, if we make lambda the subject, we are going to have lambda to be same like 2/3L. That is when we cross multiply both sides by 2 and divide by 3. We have lambda to be 2/3L. If we plug in our L that we know, we have lambda to be same like 2/3 into L is 90. So solving that, guys, we have an answer of 60 centimeters. Great. That's the wavelength of this our stationary wave. The next part is now we should stay and explain what happens to a small object at x. So for instance, the object at x will continue to remain at point x. Okay, it simply remains at point x. It goes nowhere. Okay, it is not being transmitted. Keep in mind that this is a stationary wave, and stationary wave, guys, do not transmit energy away from their source. So we don't expect this particle x to go anywhere. And better still, guys, at this point, do you see that the two waves that eventually form this our stationary wave, namely the waves drawn in broken blue lines and the ones drawn in solid yellow lines, are always out of phase at every given point. So their resultant effect at this point x simply cancels out. So we don't expect point x to leave this point. It will remain still at this particular point. Okay, an object placed at this point remains at this particular point. Wait. So guys, that's it for this. Let's now go to the next part, guys. I think we have one more part to go, right? Okay, guys, let's go. Okay, guys, I think this should be the last. It simply reads that figure 4 shows a simple pulley system used by a builder to lift a bag of cement of mass 50 kg to a height of 40 meters by applying an effort of 300 newtons. This is it. What is the velocity ratio of the machine? Oh my god, friends. If you're my student, please, I haven't taught this, although this is a Form 3 topic, wherefore I'm teaching you guys, but in Form 5. Those who are in upper seat, guys, those are my students in upper seat. These are questions that you might also meet in the laboratory, something similar to this, but not exactly this. But you might meet something similar to this in the physics practical. So please take note as well. Okay, so for the velocity ratio, just from it, guys, there is virtually no need for you to calculate, because you can just look at the answer from the diagram and you state it. Okay, but friends, generally the velocity ratio, friends, generally is be given as the ratio of the distance moved by effort all over the distance moved by the load. Okay, do you see that, friends? Do you see that? Let's look at this one, guys. Do you see that if this bag of cement, right, moves a vertical distance of 4 meters, it never means that this rope this way moves 4 meters, this one moves 4 meters, this one moves how many? 4 meters, right? So in essence, for every 1 meter change on this our cement, each of these strings must move by what? 4 meters, by 1 meter, right? So in essence, if we have a distance change of x meters, uh, by the load, we expect this our efforts to change by what, guys? By 3 times that amount, since we have 3 strings connecting this our pulley system. So in essence, guys, the distance moved by effort has to be equal to what, guys? Has to be equal to 4 times 3 all over the distance moved by the load has to be equal to what, guys? As given to be 4. So doing this, guys, we have the velocity ratio, friends, to be equal to 3. Keep in mind that it's unitless. Okay, it's unitless. Like I was saying, guys, there is no need for you to even be writing all these long stories. You can simply look at this and state your answer to be the number of pulley systems that you have here, or the number of strings attached to the pulley systems, because you have 1, 2, and 3, right? You have 3 strings passing through this entire pulley system, so the velocity ratio has to be 3. Great. The B part now should calculate the weight of the bag of cement. Oh my god, guys, from the formula W equal to mg, that's the weight is equal to what? The mass times the gravitational field strength. It therefore means that our weight W has to be equal to the mass has been given to be 50 kilograms, and G from the back of a paper is what, guys? 10 meters per second squared. So solving this, guys, we have the weight W to be equal to 500 newtons squared. The C part wants us to calculate the mechanical advantage of the pulley system. Oh my god, guys, this is also very, very simple. Mechanical advantage, guys, is given as load over effort. So, guys, the load in this case, friends, is simply your weight, okay, not the mass. Please take note. It is a weight that is 500 newtons. The effort is 300 newtons. So if we plug that in, we have 500 over 300, which gives us an answer of about 1.66. Note, guys, it is also unitless. Great. My students are going to tell you guys well that I'm very sensitive when it comes to issues like this in marking. I'm always very sensitive. Whenever you miss a unit, guys, you miss it. Once you miss a unit, you've missed the point. Okay. Now, the next part was also to calculate the efficiency of the pulley system. Friends, you have everything to solve. The efficiency of this pulley system, guys, is simply defined as the ratio of the mechanical advantage over velocity ratio times 100. So mechanical advantage, guys, we know it to be oh my god, guys, we know it to be 1.667, right? So for instance, this is to 3 decimal places. I've decided to put it to 4 decimal places to make our answer more accurate. Okay, I've increased the decimal places to put it to be 1.6667 to make the answer more accurate. Then the velocity ratio, guys, is 3. So dividing these guys and multiplying by 100, we have an answer of 55.56%. Great. So guys, this is the answer to 2 decimal places. Okay. So guys, that's it for our video. That's it. If you love the video, guys, a simple thumbs up will go a long way, guys. And please go to YouTube and share this video out with your friends. That is going to help them so well to pass their exams with very good grade, guys. I launched a poll in one of our WhatsApp group, guys, and so many students, in fact, majority of the students indicated that physics was an issue for them. So friends, that is the same issue that your own school members have. Friends, please share this video out with them to enable them have access to these contents. Have a blessed day and good luck as you prepare for your exams. Humble Mark.